Okay, number 33. Okay, let's do that there. So number 33. Okay, so number 33 says negative 15a squared minus 70a plus 120. What was the first thing I told you should do to this? Factor out the negative. So you have negative 15a squared plus 70a minus 120. First thing. Now you keep factoring. You have to test out several things, but you know your goal, this negative is just sitting out front, remember. It's just sitting out here. You're trying to turn this into something a plus something times something a plus something, right? First of all, what do you know about the coefficients of a? They have to multiply together to get 15. And what do you know about these two numbers? Negative 120, right? They have to multiply. So let's try a pair that multiplies together to get 15. What pair multiplies together? So how about 5 and 3, right? Is that okay? What about negative 120?
6 and 20. 6 and negative 20.
6 and negative 20? Now, do you consider this number to be big or small compared to the 120?
Small.
7 is big compared to 120?
Oh, I was thinking of
Oh, is it 70? Oh, that would totally change everything, wouldn't it, huh? Yeah, I copied it wrong. Look. Take a look. Take a look at that. I copied it wrong. And this thing is stuck on... It's always nice. I love it when it gets stuck on that. Yeah, it's not 70. What is it? It's not 7. It is 70. That's a lot better. So before we actually start factoring, what can we actually do? You could take out... You could keep on factoring something out, right? Because in general... What's easier to factor, smaller or bigger? Smaller. So pull out a 5, and what are you left with? 3a squared plus 14a minus what? Oh, come on, kids. You can do that. Minus 24. What's 120 divided by 10? Times 2? There you go. Break it down. Break it down. So now, is that a lot easier to factor? Yeah, you should get a little bit concerned when you see something that's too big. So you're turning this into something a plus something, something a plus something. The leading coefficients here, they need to multiply together to get what? Is that a lot nicer than 15? Yeah, there's a lot less options, because what is really the only option you have? 3 and 1. Put the higher number first. 3 and 1. Doesn't matter. You can do it either way, but that's the practice I do. So then what do you know about the second two numbers? They multiply together to get what? Negative 24. So we can just start guessing at this point. What guess do you want to make for negative 24? 6 and negative 4. So about 6 and negative 4 like that? Or do you want to reverse it? Let's reverse it. Let's just pretend that I did it in reverse. Let's say 6 and negative 4. So what do you have to do at this point? Are you guaranteed? Is this guaranteed to be correct? No. So what do you have to do? Do it out. So what's that called? Test it. Guess and you have to guess it. You have to check this. You have to test it. So what? You have this negative 5 out front. What's 3a times 1a? 3a squared. What's 3a times 6? 18a. And then you get negative 4a. And then you get negative 24. Not 22. Negative what? 24. Negative 24. Okay. So at this, does it work?
Yes.
Yeah, you get negative 5. And you end up with 3a squared plus 14a minus 24. If we had reversed it, if I had written plus 6 here, sorry, if I had written plus 6 there and negative 4 in the other spot, would it have been correct? No. If you reverse the negative 4 and the 6, you get a completely different answer. So for example, let's say instead we had done 3a plus 6 times a minus 4. All I've done is I've switched the 6 and the negative 4. Look what happens. You get 3a squared minus 12a plus 6a minus 24. Is this correct? Is this correct? No, it's not, because that right there is not the proper middle term. If you switch them, it's going to mess up the middle term. So you check it, and then your final answer is indeed what you thought it was. So your final answer would be, make sure to write it cleanly, negative 5 times 3a, what was it? Minus 4 times a plus 6. So the first step is factor out as much as you can. Factor out the negative, and then factor out the 5. Exactly. Are there other numbers that multiply together? Yeah, exactly. You could have 12 and 2. You could do 24 and 1. But the point is you'll have an intuition. So the way you get better at it is you practice it. You must practice. Okay, are there any other questions? So we had 33. Any others? Okay, so at this point, can someone tell me what's one thing we could, what's one thing you notice? Anything you notice?
They don't have 5 minus 5 next to it.
There's no 5 in that entire thing.
Oh, Z.
Z. It has Z minus X in all of it? Not the second one. So you look at all 3 of these, and what do you notice? What's one concrete thing you notice?
Both have X.
They all have X's and Z's. Is there anything we can factor out immediately? Really?
Z minus X.
Is there a Z minus X in all 3 of those terms? No. My question, you can factor something out if it's in all 3 of them. Is it in all 3 of them? No. It is, but not multiplied together. Not multiplied together. These are inside the parentheses. Can you pull things? This term right here is Z squared times Z minus X, right? So the 2 things you can work with are the Z squared or the Z minus X. Can you pull an X out of that? No, you can't pull an X out of that. Could you pull a Z out of it? Yeah. Could you pull a Z out of this one? Could you pull a Z out of this one? No. So the point is, as these are written right here, there's nothing you can factor out. Which thing is almost what you want it to be? Which one is almost what you want it to be? The middle one, right? What's the problem? The X minus Z. I'm going to give you a step here. This is kind of like not a magical step, but it's something that you can do. If I wanted to, could I factor out a -1 if I wanted to? Is that a legal move? Yeah, so it doesn't change anything on the first term, right, because I'm not doing anything to it. But if I factor out a -1, what does it become? Plus ZX, and what does the middle become? -X plus Z. And did I do anything to this other term? No. But what's another way to write -X plus Z? You have Z minus X plus ZX times Z minus X minus 2X squared Z minus X. So what was that step I did? I factored that out. Factored out -1. And what that does is it switches the order of subtraction, right? So now, can someone tell me now what can I factor out?
Z minus X.
Now you can factor out Z minus X. So Z minus X gets pulled out of the front of this. There you go. So now I can factor out Z minus X like this. And what's left? Z squared plus ZX minus 2X what? Squared. There it is. We just factored out Z minus X. So the real question is, we have factored that. The real question now is it fully factored? What do we think? Do we think it's fully factored? Do we think it's fully factored? I kind of suspect it's not. So let's actually play around with this a little bit. Which variable do we like having first? Do we like having X first or Z first? We generally like that, so let's just rewrite it a little bit. So at this point, this is pretty good. If you did that, that's pretty nice. But we need to see if you can factor more. This is a challenging one. That's a higher number. So what do we have? We have Z minus X. I'm going to rewrite this. -2X squared plus ZX plus Z squared. I'm just rewriting it with X first. That's it. Now, I don't really like having a negative out front, so what am I going to do? Yeah, so I take out negative, so I get -Z minus X times what? 2X squared minus ZX plus what? Minus Z squared, right, exactly. Yep.
Why did you get the negative all the way? You didn't take it out of the Z minus X.
It doesn't matter. It doesn't matter where I put it. It's factoring out -1. Doesn't matter what order I multiplied it. No, I just put it all the way out front because I'm pulling it out. That's it. Yes, Summer. Any last questions from the homework?
You just go up with 1.
Minus 98b squared. So you have to factor this thing, right? What's the first thing you always do when you look at a polynomial, or this thing if you want to factor? What's the first thing you always try to do?
GCF.
Try to take out the GCF. Do you always have to go straight to the GCF? No.
That's usually the first thing I look for.
No, I understand that, but what I'm saying is, can you take it out in pieces?
Yeah.
Yes. So 18 and 98, those are both what kind of numbers? So what can you pull out?
2.
So pull out a 2. 2 times 9a squared minus what? 49. Oh, look at that. What do you now know? What kind of number is 9?
Perfect square.
square.
It's a square. It's a perfect square. And what's 49? Perfect square. What's a squared?
Perfect square.
Ah, so another way to write this would be
B squared.
3a squared minus 7b squared.
What?
Oh, what just happened? What's the square root of 9?
Squares.
What's the square root of 9?
3.
Oh, we're doing square roots.
No, we're not doing them.
Oh,
We're rearranging something. We're rearranging something. What was that section? What were there were a few things you had to memorize last night? Remember difference of what?
yes.
This is the what? Difference of what?
If you took the negative 2 out, the square would be positive.
Oh, that was a mistake. It should be 2. Difference of squares. Yay! And do you remember how there's a formula for the difference of squares? So, well, you should. 2 times, what is it? 3a minus 7b times 3a plus 7b. You have to alternate it. And now you're done. Were these special patterns? Special patterns. So the first one was x squared minus y squared. Can someone tell me what that factored into? Do you remember? Someone who hasn't spoken today. Milo, what does that factor into?
X.
Yep, x what? Harry?
X plus y plus x minus 1.
Correct. There you go. And then there were a couple others that you really need to remember as well. It's x cubed minus y cubed. Anybody? Can anybody memorize that one? Anybody? Yeah, what is it?
X plus y
It's x minus y times
xy.
X squared minus
x squared plus xy plus y squared. And then x cubed plus y cubed equals, anybody remember? Yep. It's similar, minus xy plus y squared. I said yesterday, I'm going to say it again, you must memorize. You must memorize these. You must memorize. That's the second time I'm telling you to memorize it. Second time. So you must. What do you see when you look at that? Can someone tell me what you see? What do you see? That is the difference of squares. Yes, difference of squares. Difference of squares. Can you tell me how you would write it if you wanted to write this as the difference of squares? 8m squared minus
3n
n squared. So what is that going to be equal to?
8m
Plus
plus 3n
times.
8n minus.
Exactly. That is the difference of squares. Absolutely. What do you see? Here, that means new topic. What do you see when you see this? 8p cubed minus 27. What do you see? What do you see, Hannah? I see cubes. What is 8? So that's 2p cubed minus what? What's 27? 3 cubed. So this right here is the difference of what? Of cubes. Do we have a formula for that?
Yes.
Yeah, we have a formula for that. What was the difference of cubes? It was this one right here. So let's try using that formula and see what happens. So in this case, what does x correlate to? X in this case is 2p. And what's y? 3. So what is this going to factor into? 2p minus 3 times 2p squared plus 2p times 3 plus 3 squared. Can you multiply that out a little bit and clean it up? Sure. What's 2p times 3? 6p. What's 2p squared? No. 4p squared. Because what's 2p times 2p? 4p squared. And what's 3 squared? So you can multiply it out a little bit, but this was just a total direct application of the formula. The reason these were easier, or they are easier, if you remember the formulas and you recognize what? Squares and cubes. So for example, you need to remember, what are these? 1, 4, 9, 16, 25. What are these? You need to remember squares, and then what else do you have? 1, 8, 27, 64, 125, 216. What are these? Cubes. If you can recognize cubes and squares, can you use these in a straightforward manner? Yes, but you have to recognize them. You have to recognize them. So those are the formulaic ones. Can someone tell me what's really nice about this one? What's the nicest thing about this one that makes it nicely factorable? Can someone tell me the nicest thing? What's the nicest thing about that trinomial, Milo? It does have a number, but what is it? It's 1. The leading coefficient is 1, exactly. When the leading coefficient is 1, you're like, yes! Because either it'll be nicely factorable or it'll be prime. In this case, you're looking for two numbers that multiply together to get what? 25. And add together to get what? 10. Can you tell me two such numbers? 5 and 5. So if it's 5 and 5, what does this factor into? X, P. Sorry, thank you. Yep, P what? P plus 5 times P plus 5. That one's pretty nice. Do they get slightly more complicated? A little bit. What about this one right here? Let's just do one of these. 2k squared minus k minus 6. What's the slightly not nice thing about this one, Emmett? What's the slightly not nice thing about this one? Yeah, the leading coefficient is 2. That means you're going to break it apart into two things. One of them has to be what? 2k, and the other one has to be what? 1k, exactly. Are there any other ways to get the number 2 when you multiply it together? At least it's a small number, right? Well, yeah, but we're limiting ourselves to integers. That's a good point. Could I break it apart into like 1.5 times something, right? Sure, but we're not doing that. The other two numbers need to multiply together to get what? So let's just guess. So now you just guess. What two numbers multiply together to get negative 6? How about negative 3 and what? 2. At this point, are we guaranteed to have the right answer, Aubrey? What do we still need to do, Nick?
Do it out.
Yeah, do it out. We need to test it. Exactly. So let's do it out. 2k times that is, then you have plus 4k minus 3k minus what? So are we close to what we want? We're really close. What's the only thing that's not what we want it to be? What's the only thing? We want that to be what? So did anybody want to guess as to how we just change the sign? You just change the signs right here. So what are we going to turn that into? Something really similar, right? Yeah, 2k plus 3 times k what? Still, what should we do just to be sure? Test it. You get 2k squared minus 4k plus 3k minus 6. Does this come out to be what we want? Yay, smiley face. Frowny face, yes. Gross and scary. Ready? I'm going to do one thing right here that's going to help you because I told you I would do this. What can you factor out of the first two?
Y.
You can get better than y. Y squared, and what's left? What can you factor out of this one? What's left? Is that the magical thing that you're always looking for? Because what do you have here? You have, ooh, yay, yay. So what can you factor out of both of them? So you have x minus y times. So I'm going to show you how I can change this by a little bit just to show you what you could be presented with. Theoretically, could I have written this in a different order? Could I have written it as x squared, sorry, not x squared. Could I have started this a little differently? X, y squared, let's say I wrote it like this. What's the only thing I changed? All I did was change the order, right? If I change the order and don't call it grouping, does it become a lot harder? I didn't really change much though, right? What's the only thing I changed? I only switched those around, right? So that's why grouping is kind of dangerous because it's only super useful right here, right? But why? I told you it and it was in the right order. So just be prepared.
You can't group it now?
No, you can. I could just say, if I just said factor this, to factor this by grouping, you would have to try grouping in the first place. And you would have to switch the order so you get it in the next grouping. You can. I'm just saying that this is a setup that's a little harder. Remember how word problems, once you got to the equations, they were pretty easy, right? What was the hard part about the word problems? Getting the equations, right? So a word problem is just a set of equations, right? You know how to work with equations, but going backwards and starting somewhere else can make it harder. Grouping is a little annoying because if you realize you can use it, awesome. If you don't, it can be really hard. And also, is grouping always going to work? No, grouping's not. What's left? 5k plus 1. And then what'd you factor out? Negative.
9.
So what are you left with? Awesome. So what do you factor out? 5k plus 1, and what are you left with?
4k squared minus 7.
And are you done? That right there is awesome, but you can keep on going. What do you see? Take a look at that. What do you see, Hannah? Look what you see right here, difference of squares. So that's 5k plus 1 times what? 2k what?
I say 2k plus 3
Times
2k minus.
this right here. Nick, if you got to here, that is awesome. That is fantastic that we got to there. But this right here, can you keep on going a little bit? Yep, this is difference of squares. Difference of squares.